Hello, my name is Luis Andra and I'm from SMA 1 1 Bandung. Now I am going to present my research, decimal expansion from the difference of two irrational roots. Introduction. Let's consider two numbers A and B. Both are non-square integers. We take the example 7 and 2. Then the square root of 7 and 2 is taken and subtracted. The fractional part of the result is taken and the integer part is removed. If we now only know the sequence, would we find back A and B? The main aim of this research is to determine the proper condition for resulting in unique decimal sequence. Research methodology. Notations used in this research are a pair of positive non-square integers a and b, where a and b will be less than upper limit k. K could be represented in the form of k equals to 10 to the power of m. P is the difference between square root a and square root b. S is the fractional part of decimal expansion of p. And n is the number of decimal digits of s. So in the first stage, it has been tried for a small upper limit for k and n, in which k equals to 1000 and n equals to 10. And then we list all pairs of a and b. After that, we list s to find duplicates, where duplicates here is the different pair which generate the same s. And then the cause of duplicates will be studied. In the second stage, we implement the search algorithm. First, s is given until n digits. Then we set the upper limit k. And then we find back a and b by brute force. Memory usage. Only the last calculation will be stored in memory. And time will be noted to find the correlation between m and k with time. Expected result of this stage is there exists a condition where the problem finally becomes practically unsolvable and requires a really long computation time. And the implementation, it could be a new strong encryption or decryption algorithm. Result and analysis. On the first stage, where the only square number filter applied, there would be many combinations with identical decimals. For example, when A is 867 and B is 12, S is 0.898076211135, and so on. And when A is 972 and B is 27, it results in the same identical S, 0.98076211135, and so on. As a consequence, eliminating integers having the same square free factor is applied as a new filter or as the second filter. The definition of square free factor is defined by the example. For example, take A 867, and the prime factorization of A is 3 times 17 squared, and the square free factor of A is 3. Take B equals to 12, and the prime factorization of B is 3 times 2 squared, and the square free factor of 12 is 3. Therefore, the pair 867 and 12 will not be considered. And then, new filter is tried where both A and B are non-square free numbers. Duplicates are still found, but only due to their similarities in the first n digits. The result of analysis is no correlation found between A and B, which results in the same value of S. And the phenomenon could be considered as a coincidence for the first n digits to be similar. Total combinations compared from filter 1 and filter 2 have no significant difference for m equals to 1. For m equal or more than 2, total combination from filter 1 is roughly 2.5 to 2.6 times more than filter 2. There is also striking findings in this research, especially in the first stage, is when the value of n is increased by 1, total collisions decrease by roughly 10%. There is also a pattern observed in this stage of the research that is for k to be 10 times larger, n needs to be increased by 3 to 5 for resulting in zero collisions. Here is figure 1, illustrating the relationship of n to m. Second stage, a search algorithm has been implemented for n equals to 15. For A and B to be less than 10,000, only a single solution is found. For A and B to be more than 10,000, there is still a single solution for the test number where the test case is A equals to 19,404 and B is 10,647. Only one case tried just for measuring search time, because this algorithm is a really time-consuming algorithm, and the time taken for the previous test case is almost 2 hours. To ensure the upper limit for no collisions, more cases should be tried. Figure 2 shows the relation between k and time. As k increases, the time fits with a second-order polynomial graph in respect with k. Therefore, the algorithm time complexity is O k squared, as expected from the brute force algorithm. Conclusion. The conclusion of this research are pairs with no common square root factor seem to generate unique decimal sequence, and minimum digits to avoid duplicates is 3.9 times m minus 1. Future work. For future work, more research should be conducted to apply larger integers or to develop a better algorithm to replace the current brute force algorithm. And a functional encryption and decryption algorithm could be developed as a proof of concept as well. Thank you.